You guys will get your tests back tomorrow. They are mostly graded. I just needed my TAs to help me because I did a lot of grading this weekend, but they needed to score them for me and write them down in my grade book. So you should see that in Run Web tonight. And we can go over those tests tomorrow. But for right now, we are starting in on a new section, section 6.5. But to do that, we had an opener here at the beginning of class while I graded your notes. So for anyone that came in late, I have a couple more rows to grade notes from chapter 6A. And I'm going to review a couple things on notes because some of you guys have gotten a little lost, a little disorganized. But the nice thing is we're starting a new chapter today. So we can all start on the same page as, in the sense of starting over. You've lost notes, you've lost pages, you got disorganized. Let's get back in. And that way, hopefully, this next chapter you can get a nice 100% on notes if you do them correctly. But right now, we're not in notes yet. We're in the back of our homework spiral. And we're doing our opener. If for any reason you ever have questions and you just want to bring me all your math stuff and say, help, I got disorganized, I'll help you get organized because it should be really easy. Come into class, you flip to the back of your spiral and say, let's go. Flip to the front of your spiral if there's homework, let's grade. And then you flip into your composition book, let's take notes. That's it. That's what you need for class every day. Okay. Number 1. Someone tell me some step, raise your hand, that you thought to do to try to solve. Well, hold on. What are we solving for? Everybody, in the count of 3.
X.
1, 2, 3. We're solving for X, right? So, Trey, what's something you thought we could do? Just one step. Okay, we could add 2X. For the purpose of maybe combining some like terms, getting them on the same side, right? So if we add the 2x over here to join the other x term, we have 3 x's and 2 x's, which makes 5 x's total. But we're not totally done yet because what do we still have in there?
We need to add the 1 to the other side.
Good. We need to add the 1 to the other side. So when we add 1 to both sides, we will end up with 5x equals 5. And then how do we get rid of that 5? Division, because it's 5 times x when they're next to each other, right? So divide by 5 and divide by 5, reduce and reduce to 1. Final answer, x equals 1. Final answer, x equals 1. Give me a quick thumbs up if you got there before me. Whether or not your group helped you, you get there before me. Okay. So this was a review from algebra equations where it was only, or there were only x's. And we were trying to get everything simplified down to get x alone and a number on the other side. Combining x terms and combining constants or numbers, but having to do it the legal algebra way, which says what you do to one side, you must also do to the
other side.
Because we got to keep it balanced, right? That's a chemistry thing, too. Keeping everything balanced. Now, why is number 2 one step harder? 2 equations, and with those 2 equations also comes 2 variables, right? An x and a y. So we're not just solving for x anymore, we're solving for both x and y. This was actually from the very, very end of Algebra 1A. But super, super important for moving forward. We're not learning it today, we're just kind of reviewing it. But as you guys are looking at number 2, does anybody have a step to start?
Oh, yeah.
Yeah, you can
just combine the 2.
Yeah, how do you combine the 2?
You put x minus 7 equals negative 3x plus 1.
It's technically called substitution because you say, well, if y is this, I can plug it into the y spot back here. You're actually doing a substitution, pulling the y out and putting the x minus 7 germ. The last one. Focus it. So you can plug x minus 7 into the y spot. So I have x minus 7 equals negative 3x plus 1. Now, doesn't this look a lot like that one?
Yeah.
So are you guys okay if I go ahead and do the same? Whoa, that makes no sense. What should I be adding? Because I want to cancel it out. 3x. I'm going to follow similar procedures to what we did in the other one. Because Trey added the x term last time, so I'll add it over here. When I have a negative and a positive, isn't that just a 0 plus 1? Which is just 1. And I have, hey guys, how many x's do I have? 4. Because there's an understood 1, yeah?
Yeah.
Good. So I have 4x, and then the minus 7 just comes down. I then have to go ahead and add 7 to both sides, which means 4x equals 8. And what would you guys do to both sides in order to get x alone?
Divide 4 both sides.
What's 8 over 4?
2.
Now here's the struggle on this one. I was supposed to find x. I was supposed to find x and y. So I have x, but I'm done, right? Like there's no.
Oh, you got to plug it in.
Good. Once I find the x, I have to come back and I need to substitute back in. So I can come now. I could go to either equation technically, but I don't know about you guys. Does this one look easier to you?
Yeah.
So if I was substituting, y would equal not x minus 7, but 2 minus 7. And 2 minus 7 is negative 5.
And then you put the graph.
We could have graphed, yeah, like 2 lines, and 2 lines intersect in Andrew and Daniel. We good? Attention back up here. Isaiah's remembering that this could have been a line and that could have been a line, and 2 lines come together at a point of intersection. And so we could write this as a snazzy order pair instead of just an x and a y. And that would have been the point they came together. Okay. So solving equations. Solving equations. Now guys, I showed you there was 1 and 2, and I wanted to go over the answers before I let you loose on trying to finish the warm-up. So what if I give you 3 and 4? But you guys get to choose just one. In your groups, choose just one to try. You don't have to try both. Just try one more. Whichever one looks easier to you or looks a little bit better. Choose 3 or 4. Real quick, in your groups, talk it out, and then go for it.
Yes, I agree.
5x plus
I agree.
7. Right? Go. I knew it. Negative 9.
I agree. I agree. Good work.
So you're really
27.
Did you solve the first part first?
Yeah.
Graph it? No. Wait for it.
I watched the other example.
-2.
And then don't forget this one. Oh, so you divide it by 4, and then you cross this out, and that's 4. And then underscore going to A. So X equals 2.
Alright guys,
The top.
I want you to vote for the problem that you chose. How many of you guys chose number 3?
We did.
How many of you guys chose number 4?
No.
Just you guys, bro? You guys did number 4? Okay. For those of you that chose number 3, those of you are finishing, well, let's go ahead and quiet down, and if you are still finishing, whisper, whisper, whisper. For those of you that chose number 3, does substitution sound like a good idea?
Yeah. No. Yeah.
Yes.
Meaning, did you take 5x plus 7 and plug it into the y spot?
Yes.
Yeah.
Okay, so if you did that, you would have had 3x plus 5x plus 7. Technically, there should be parentheses, but the plus makes it everything okay. You should have had that. At which point you would have probably combined, since it's on the same side, it's good. Go for it. 3x plus 5x would be 8x's, right? And did you guys subtract the 7 from both sides? Yeah, good. 8x equals negative 16. Divide both sides by 8, and x equals... Good. Except, oh, look at your equations. We're supposed to solve for x and y. Andrew, go ahead. What's up, bud?
Why would you substitute the one that says y equals into the y when it's plus y?
Well, see how these are the same? The y and the y. Since there's a y here, I can say, who are you, y? Oh, there you are. Y is. Remember, every equation is really a sentence. So 3x plus y is negative 9, and y is 5x plus 7. So if that's who y is, this is his like identity or his equation, his expression. I can actually say, okay, y, I know who you are. We use the word substitution. I'm going to plug you in. So we went ahead and said, okay, we don't need to leave the y there. We can plug in his other form that would be more helpful. So even if you want to go back to Marvel, you want to think Bruce Banner and the Hulk. Sometimes it's much more helpful to have Bruce Banner. Sometimes it's way more helpful to have the Hulk. It just depends on which form we want. And so the y wasn't helpful up here. But his 5x plus 7 form, oh, that's much nicer. Does that kind of make sense?
Yeah.
So we kind of changed his form. Now, we have the x, and just like we did before, we have to come back and substitute because we don't want just y's expression. We want y's number. So we have to go ahead and substitute for x now. And y is equal to 5 times who plus 7? Who is x? Negative 2. So I'm doing the same thing kind of, Andrew, in this. I'm saying x's other form is, or value is negative 2, so plug it in. And negative 10 plus 7 using PEMDAS would be negative 3. So if we were to use what Isaiah said a second ago, we could go ahead and make a point out of that, negative 2, negative 3. Now my one group that did number 4, I'm going to do it fast because the other groups didn't. This one, actually, substitution would have been really, really, really hard. It would have been a lot easier to actually do something that we call elimination.
Oh yeah, 2x.
And you want to make a match so you can take that. I know, it's been a while. But this is a hard one because it's not even like easy to multiply. So it would have been a little nasty. If I were you, I probably would have multiplied the top one by, I don't know, I like multiplying by 5. So I probably would have chosen this so that the 5 times 7 would be negative 35. And I would multiply this guy by a negative 7. You're changing the coefficients so that if all goes well, I can multiply. Now I had to distribute my 5 to everybody. Miss Sutherland would have taught you this last year. I would have had to distribute my negative 7 to everybody, which there's a lot of multiplication to keep track of. But do you guys see how these two now match? Yes. And the goal was making one term, one variable term match so we can take it out, so we can eliminate it. What is it, happiness? So I know some of you guys didn't try this, but you're just kind of reviewing and remembering a lot of things having to do with solving equations. So what's negative 35 plus 35? What happens? 0. But we're not just doing this one. That's really nice, that's 0. We can also do negative 15 plus 7, which would be negative 8. But who did I forget? Yeah, 40x minus 42x would be negative 2x, right? Careful, negative or positive 4? Good, because if you divide by a negative 2, doesn't x equal a positive 4? Oh, wait. What are we solving for?
Y.
A common equation in order to get the y and the x. So once we have the x, that's good, but we still need the y, right?
Yes.
So,
It's -7 equals
yeah, it's kind of nasty. We just have to come back to the very beginning, take an equation, and plug in an x. So you guys, I don't know, what do you like, the top one or the bottom one? Okay. Well, you can do either one. So you can go for the bottom if you like that one better. But a lot of people said the top, like you guys heard, so I'm going to go ahead and, do you see how I've rewritten everything up there except for what? Yeah, I've rewritten everything except for the x, because what am I going to put in the x's spot? Mm-hmm. So then I have to do some PEMDAS, like multiplying to get 32. And then I have to, now this is where signs get a little bit nasty, a little bit tricky. If I can write the number 32. I have to divide by a -7. Most of you didn't try this problem, so I'm kind of just going quick. But your final answer would be 4 and 5. But actually, I think number 4 was probably the hardest out of all the ones up here. Okay. Why were we doing this one? What was the same in every single one? You were trying to solve. Plugging in substitution was always somehow a part of it, at least for the ones with x's and y's. But we were trying to solve for the variables. Sometimes just x, sometimes x's and y's. And when there were x's and y's, the work got a whole lot longer, right? I just went around and did a notebook check. And as I went around and did a notebook check, some of us got really messy and really behind in our notes. So I want you guys to either, because some of you didn't have your notes today, either have out a blank piece of paper just so you can keep track with what we're doing. Or just turn right after section 6.4 to go to section 6.5 for notes. The reason why we were doing a warm-up with so many equations that we needed to solve is because, check out the title. What do you see?
Okay.
Okay. We're going to be solving equations, but what kind? It is still chapter 6. We're still dealing with that x up in that exponent, like decay and like growth. But now, somehow, we're going to be solving equations with those guys. So it's going to look a little different than those ones from last year with x's and y's and just addition and subtraction. Now we have exponents. But the nice thing is, these can get really, really, really nasty, like pre-calculus level nasty, and we're not seeing those ones. We're going to see the super, super introductory basic ones. Now, for those of you that want to get back on track with your notes, all of us are supposed to have a composition book that we use for notes, separate than our homework spiral. Homework spiral is for so we can keep it nice and organized. And some of you that do it on separate papers, like it's falling out all over the place, you lose them, it's just a mess. Homework spirals are for homework, and then in the back of our homework spirals, it's for openers. But this is for notes. So those of you that don't have one of these, get one. You can start right now with the rest of us at chapter 6B. Now, what are you technically supposed to be keeping up to date in the front page? Table of contents. With each section notes, and we've done so far section 6.1 to 6.4, and Brooke's been doing a great job of writing down the page numbers. Of page 1, I can go find her page 1. There's her 6.1. If I want to just go find her 6.4, I can turn to page 6, because she's been numbering her pages right up here. And there's your 6.4. I want a section at the very top. Anytime you start a new section, like today, everyone should be at the top of their paper. I want the section number, 6.5, the section title. This one's always in parentheses. You don't have to write it, but you can read through it. And then I just want you taking notes. Now remember, we usually spend a few days taking notes in a section, right? So you'll have a few days for each note. Here's like section 6.2, we had a few days at 6.2, and then 6.3, and then a few days for 6.3, and then 6.4. You can write on both sides, or just write on one piece. But for those of you that it was really stressful for me to ask about your notes today, it's not meant to be. It's meant to be a book you bring every single day. you take home with you every single night. Because I give you hints, we do examples, I show you formulas that you're going to be using. It's a super important place to have information that's way shorter and way simpler than the book for most of you, if you just keep up. And it should be an easy 100% grade, which is worth about 5 homeworks. Now, homeworks are worth points too,
Yeah.
but notes are really important to me, so I grade them. Now, some of you are like, okay, well, I got messed up, or I was absent, or I forgot my notes and I took it on another piece of paper. I talked to a lot of you guys just now in class, reminding you that Google Classroom is a place where you can go to find the notes we've taken for class. Now, I can start posting them every day if that would be helpful for you. I don't mind. I can put the PDF in the announcements that I do every day about our homework. If that helps, I can start doing that. But another place that you could have gone for last chapter, because that's starting now in chapter 6B, and some of you need to get your notes all nice, neat, and organized for me to grade. If you hit the classwork tab right here, there are resources. And the resources can take you to your folder, your YouTube channel, but also your folder. And in your folder, there are PDFs of all the notes that we've taken right underneath class notes. And so for some of you that have lost your notes, or you've never taken them the right way, or you were absent for a certain section, yes, you can reach out to a friend. But you can also, well, you don't need to take notes on that. That was a class activity. Remember, some things are class activities. But you can go through and you can find the section of notes that you are missing, and you can take notes. And I have 6-1, 6-2, 6-3, 6-4. And every day in class, I add a little more to it. I add a little more to it. I add a little more to it. So you never have to worry about losing your papers. You never have to worry about being absent for a day. You can always, remember, you can go watch the lecture on the YouTube channel. And you can also see I'm recording down here. And you can also go find the notes. Okay, so those of you today, your notes were not ready. What can you do for tomorrow? Catch up. I don't know what else to do besides just explain it to you and then hope that you do it. But once again, if this is too much information for any of you, come see me and I'll sit you down and I'll pull it up on the computer and you can use my computer in order to copy down notes, okay? I would love to give some of you, well, right now, higher scores than zeros, my ones that are missing their notes. And some of you, if you were missing like just one section, I'd take off a point or something like that, you can still come in and we can catch it up. What is this section 6.5? You guys have the title down? Everybody? The number and the title, solving exponential equation. It starts off really easy. If the bases are like. Basically, this entire section. 2 camps. If they're like, if they're unlike. If they're like or unlike. If they're like bases or if they're not like bases. If they're like bases, we love it. Because there's this really crazy property in math. I'm not making you write it. I'm not making you memorize it. I'm just telling you it's there. If we can make the bases match, and we have an exponential piece on one side and an exponential piece on the other side, and if the bases match, then we ignore it. We love ignoring stuff, right? We love ignoring stuff. We love ignoring difficult things. It's not always safe, it's not always good, but in this case it is. With like bases, ignore the bases. With like bases, ignore the bases. So if I was to give you an example, like 3 to the 2x equals 3 to the x plus 3. If I was to give you an equation, now it looks horrible, it looks horrendous, except what did I just say we get to do with like bases?
Yeah.
Ignore them. Meaning, are the bases alike?
Yes.
Sweet. Let's ignore them. So we can just say 2x equals x plus 3. The only way that those powers, that this equation can be true is if the powers are true, since the bases are alike. With like bases, we get to ignore them. We get to say, hey, as long as they're alike, sweet, sweet, let's go here. We get to ignore them. 2x equals x plus 3. Is this something we can do?
Yes.
Yeah, it is. Looks so hard a second ago, but all of a sudden it's possible. You guys see how I'm going to subtract x from both sides? Now, careful. There's an understood 1, so 2x minus 1x is...
X.
Oh, no, I have to go find... No, I don't. Are there any y's for me to even worry about?
No, sweet.
That wasn't bad, was it?
Nope.
So if the bases are alike, all we gotta do is ignore them. But the problem is, do you think those are the only types of equations we're gonna see?
No.
So let me go ahead and show you another type of example. Oh, let's not do this. What if they're not alike? And for sake of us being able to focus on just one problem, let me make this one big. I know it's going to be kind of fuzzy. What if we don't have like bases? If we have like bases, we just get to ignore them and solve the resulting equation. But what if we don't have like bases? With unlike bases, we make the bases match.
That would be 3.
How did Isaiah just figure out that x equals 3? He thought about 125. And from all the 6, 1, 6, 2, 6, 3, 6, 4, did you guys remember quite a few times we figured out that 125 was 5 cubed?
Yeah.
We divided by 5, divided by 5, divided by 5. 5 cubed, 5 times 5 times 5 made 125. As soon as you're able to write that, I'm made. It's good. It's perfect, because as soon as the bases match, what do we get to do? Ignore them. Now this one, was there even anything else to do? No. But if you're given something crazy like, well, let's do this one as our last example of today. That's nasty and disgusting, I apologize. What if we were, oh, my elbow messed it all up. What if we were given this dude?
Times 2, 3.
What can I rewrite 4 to be with the 2 as its base? Isn't it 2 squared? Now, this one might be a little bit trickier, but guys, do my bases match?
Yes.
How do I ignore? Maybe I should rewrite it 2 to the 2x. Ah, now, okay, when the parentheses are gone, remember PEMDAS, parentheses first, power to a power, and multiply. Now what can I do? I can make it match. Oh, I already did make it match. I can ignore it. As soon as I get the bases to match and the exponents are ready just to be set equal to each other, I can just go for it and say, haha, I don't care about the bases anymore. All I care about is their exponents being set equal to each other. All I care about is their exponents being set equal to each other. Is this something now we can solve?
Yes.
So here's what's going to be tricky in homework. And I forgot what the page was, so I was having some issues in writing it down. But your homework is just going to be numbers 1 through, let's just go 1 through, maybe not 12. That might be a little too crazy. Let's do 1 through 9. Numbers 1 through 9 on page 329. I just want you guys to get a feel for it. Page 329, numbers 1 through 9. Now, quick heads up. I put numbers 1 through 12 on RunWeb, but I decided the ones like 10, 11, 12 got a little hard. So let's go ahead and just do 1 through 9, take a picture of it on the way out the door. If it's alike, we get to ignore. And if it's not alike, make them match. All right, well, kids, come in tomorrow and we'll see how it goes. But right now, I'll see you in chapel.
See you in chapel. Here, let me take that.
I'm tired.
Move your head.
Probably just about to go.